We will be working through a lot of stoichiometry problems for this quiz. Remember, the heart of every stoichiometry problem is a mole-to-mole ratio that's based on a balanced chemical equation. A quick reminder of some of the ways we've learned to calculate moles. If you're given the mass of a chemical, you want to take the mass and divide by the formula weight. If your chemical is in a aqueous solution, moles is obtained by multiplying molarity times the volume in liters. And if your chemical is a gas, 1 mole of gas at STP is equal to 22.4 liters. In this problem, the chemical of initial interest is in the form of a gas. So we have gaseous hydrogen, H2 gas. And we want to compare that to another chemical, hexane. To compare one chemical to another, we need a balanced chemical equation. So we need to first balance this unbalanced chemical equation that's given to us. This is our balanced chemical equation. If you're having a little difficulty balancing chemical equations, then you need to review that because there is a lot of balancing to be done on this next quiz. Suffice it to say that if we go and look at the number of each type of atom that's present in the reactants and the products, we're going to see that we have a match. There's 6 carbon atoms in the reactants and 6 in the products. Oxygen, 6 and 6. Hydrogen is also matching. 26 hydrogen atoms here, and we have 26 hydrogen atoms on the product side. Now that we have our balanced chemical equation, we can work through our stoichiometry problem. Let's remind ourselves we're comparing hydrogen gas, there's hydrogen gas with its coefficient, to hexane. So there's hexane with its coefficient. So we start our calculation. We want to have moles of H2, and we're given its quantity in liters. So we need to use the conversion factor that 22.414 liters is equivalent to a mole of H2. And see here how the liters cancel out, and multiplying these numbers together has a result of generating moles of H2. Now that we know moles of H2, we go back to the balanced chemical equation to generate the correct mole-to-mole ratio so that we can compare H2 to hexane. Now right here is where a lot of people have been making mistakes, the mole-to-mole ratio. This is the correct mole-to-mole ratio, 1 to 13. We know that because we can see that moles of H2 cancel out, and the coefficient that's associated with H2 in our balanced chemical equation matches that in our mole-to-mole ratio. In the numerator, we have 1 mole of methane, and that corresponds to the right coefficient associated with, not methane, hexane, in our balanced chemical equation. This mole-to-mole ratio tells us that we need to divide by 13. At this point in our calculation, we know the correct amount of hexane, how many moles of hexane. However, in the statement of the problem, we want our answer given in grams. So we're going to have to determine the formula weight of hexane and set up our last conversion factor. All right, now down here I showed a reminder of how to calculate the formula weight, and we're going to use the formula weight as a conversion factor. We know that we have to have moles of C6H14 in the denominator so that they can cancel out, and our final unit in our answer is going to be grams. So now we can just churn out the math. Everything in the top indicates multiplication. Numbers in the denominator indicate division. All right, so we do the math and we get our final answer. We'll go back and worry about sig figs. 2 sig figs here. This is 5. These This mole-to-mole ratio, as all mole-to-mole ratios, is an exact number, so is not going to impact our sig figs. 4 sig figs here, therefore we're limited overall to 2 sig figs, and our final answer is 2.5 grams.